Hi guys, I'm Shreyas Kapale. I'll be basically talking about dask in more practical terms. Now, you can download this tutorial from the dask official repository, and you can basically get these Python notebooks to try out yourself. So let us actually start with something called as dask delay. So dask delay basically creates task graphs for your functions, and basically which help you in distributed computation. So instead of actually telling a formal definition, I would like to go ahead and actually show you some example. So yeah, so before I actually do something in Dask, I will basically start a client which is actually already running. So yeah, I'll talk about clients on a more later note. Yeah, so what are the basics? Okay, so of dash delays. To look at actually how dash delete works, I'll basically use this as example. Let's say you have two functions, increment and add, and both functions basically take 1 second just to emulate the processing time. Uh, and also you may consider this as maybe data processing or data loading, anything you want to consider it in more practical ways. Now, if I actually run it and run the function, yeah, so you can see that it takes approximately 3 seconds. So as you know that each function, so it's calling two times increment, which is 1 plus 1, which is 2, and then it is running add, which also takes 1 second, so totally 3 seconds. So it's taking 3 seconds to actually complete this whole thing because it's going sequentially and not in a parallelized way. So let's actually parallelize this using dash delete decorator. So yeah, so now let us actually parallelize this whole thing by actually using delayed. So let's actually use apply delayed to these functions. Now as you can see that the if I run this, you can see that the time taken is actually 473 microseconds. The reason for that is basically it is actually not um, computing the values. It's basically building a task graph, or you can say it is lazily evaluating the map that it has to go through to actually print out the result or give out the result. So now if you actually want to compute something, you can actually use uh, the compute function. So if I actually run it, and if you see the time, it is approximately 2.02 seconds, which is much less than 3 seconds. As you know that if you actually if you actually see what z object is, z is basically a delayed object which is comprises of your functions. Now if you actually visualize z by using the visualize function, you will see that it basically built a task graph, basically same like your TensorFlow task graphs or the task graphs. So if you have used TensorFlow, you might know what is a graph, task graph. So it basically built a task graph over here. So there are two functions that are actually going parallelly. So delayed attribute actually does this for us. So it sees the similar patterns in the functions or signatures, and then it basically uh, make parallelize it and reduce the time for processing. Now one more one more thing I would like to actually share is that instead of actually using writing delayed and passing a function through like this, you can basically use a delay delayed construct decorator for functions like this. So whatever is under the this delayed decorator gets added to your delayed object. So yeah, so after actually computing, you can also I'll also take one more example wherein this can be useful, is that in case of for loops. Let us say there is an array of data like 1 2 3 4 5 6 7 8, and we have a sequential code to basically compute the sum of this array. Now one way you can actually do is that you can create a for loop, and then you can run the increment function x times, or so x times, and then you can append the values to result and then create a sum. So the increment function will basically take 1 second for each call, because uh, that we have implemented in previously. So yeah, so it has to run for 8 times, so basically the total time will be obviously 8 seconds. to actually sum the whole result and get it. Basically it takes 8 seconds. Now if you actually use a dask delayed object, so you can see that if I use delayed over here and if I use delayed with some function, you can see a very large difference when it comes to that. So if I run this, and then run, and if I run this code, yeah, so basically it takes 1 second, because if you actually, let's say if you see the task graphs, let's say if you see um, total.vi visualize function, and if you see the task graph, you can actually see that all of these functions are actually parallelly getting computed, and then you are getting the sum. So yeah, so that's it for delayed objects, or I mean dask delayed. Uh, Now let us actually get into something called as dask arrays. So what are dask arrays? So dask arrays are basically nothing but larger arrays made up of smaller numpy chunks. So in terms of technique, if you see in technical words, it basically uses blocking algorithms for applying parallel computations over the data. So, and it also is advantageous when it comes to data that cannot be fit into a memory directly, and it actually loads it lazily in a way, so you can basically compute them based on the need. So yeah, so let us actually look at an example over here. So if I wait, let's create some random data points. So I've created some random data points. Now, as you know, the client is already running. So yeah, so let us actually take this data and then see what is a blocked algorithm. Okay, when it comes to NumPy, let's say if you are applying a blocked algorithm to NumPy, so what is happening is that when I so the whole data is first loaded. Okay, when after it gets loaded, or let's say the whole data is iterated from till end, what we basically do is, instead of putting everything on the same this thing and then taking the sum, we take smaller chunks of the data. For example, from I to 1000, this is 1 million. So a chunk basically is a numpy array. So we basically take out 1 million of this whole chunk, so of this whole data as a chunk, and then we take some of that chunk, and then we add it to sums, and then finally we take some of those smaller chunks. So this is what you call a blocked algorithm for computing parallelly, or not parallelly, when you say, if you actually like to make it more memory efficient, if that is what we are talking about here. Now this same thing is actually done in a single line by dask array. Now similarly, a mean example is given over here. It is taking chunks and then adding the chunks and then taking the mean of that. So a simpler way of doing that, or using a blocked algorithm, is by using a dask array. So dask array actually comes with uh, pre-written blocked algorithms. So you just basically have to take the data array, then from data array, then you have to set the number of you have to set the chunk size of 1 million. So directly it will basically, if you run this, let's say you run this, you can see that the whole array size is 4 GB, and it's broken down into chunks of 4 MB. So and so 1000 chunks. Now if you actually want to take the sum, we can run this. So the problem here is that it's not actually taking the sum right now, because it has just lazily loaded it. To actually get an sum of the result, I mean the sum of the whole thing, then we have to apply a compute over that result. So if I press compute, it basically gives out the value, which is same even if we do this. So yeah, these both are same in terms that dask actually provides it pre-built.
So yeah, by this we wrap our session, and we you can always visit Dask tutorial to actually go through these Python notebooks, and you can always play around it and learn more about Dask. So yeah, thank you guys for listening to us.